Welcome, video example 7, Unit 3, Chemistry 1B. We do another calculation related to electrolysis, but this time we're going to work in the reverse. So we're going to calculate time from a mass. Okay, so the question says, how long must the current of 0.8 amperes flow to form 2.5 grams of silver metal in an electroplating experiment? And the reaction is given on the screen there for you. We can use the same flow chart where we start with the mass. We work with the molar mass as the conversion unit to get the number of moles. We then work with the moles of reactant and number of moles of electrons as conversion unit to get the number of moles of electrons in terms of Faradays. We then use the Faraday constant to get the charge. And once we have the charge, we can work with the current and find the time. Okay, so we first need to calculate the number of moles of electrons required. So we have the mass. And then we multiply this by the molar mass, okay, in terms of a conversion unit, such that we have the grams cancelling out and we're left with the number of moles. From the equation, we know that 1 mole of electrons is related to 1 mole of silver. So therefore, the total number of moles of electrons is calculated as follows. We can then calculate the charge, okay, by multiplying by the Faraday constant. So here is the Faraday constant. And we end up with 2,236 coulombs of charge for that number of moles of electrons. And then we can calculate the time, remembering that time is equal to charge divided by current. And we can do the conversion, making sure that we know that this is a conversion unit to clear the coulombs. It's ampere per second for 1 coulomb, so that the coulombs cancel and the amperes cancel. And then of course we need to, if we want to get it into, in this case this is 60 seconds per minute, okay, so that's such that the seconds cancel here, and actually then this becomes minutes, and we see that it's about 46 minutes to get that amount of silver electroplated out. Again, if you're good with dimensional analysis, you could do the entire thing in one step. And that's what they do at the bottom of the slide there. It can be a little confusing, but it can be done in one step.